All right, finally, we've got sp hybridization. And so here we've got two things attached to our atom. And so an example of this is acetylene, where these two central carbons are now sp hybridized, right? They've got one carbon and then one hydrogen, but it doesn't just have to be carbon. It can be other things like this HCN, right? Both the carbon and the nitrogen are sp hybridized, right? The carbon has a hydrogen and nitrogen. The nitrogen has a carbon and a lone pair. Both have two things. And so as this implies, it's a mixing of one of the s orbitals and one of the p orbitals. And so what we have here is a sphere, and then one of our dumbbells, they mix together, and then what we'll get is essentially just another dumbbell, but this is two sp orbitals, right? So here's one of them. That's one orbital, and then the other side is a second orbital, right? And so then we have two leftover orbitals, and they're both p orbitals. So let's take a look at how this structure would look. So we have this carbon triply bound here, and then let's take a look. So we've got carbon, carbon, hydrogen, hydrogen. We've got an sp orbital. That's the direct overlap between these two carbons. That's that bond right there. And then the same thing for the hydrogens. So an sp orbital from the carbon, and then just a regular s orbital from the hydrogen. This picture's a bit exaggerated, as you can tell, right? So that takes care of those guys right there. And so we have 3 sigma bonds. But now we have 2 leftover p orbitals, right? One of these p orbitals will be on top of and below the carbon, right? They'll each contain 1 electron. And so we can get bonding like this, right? That explains the second out of the triple bond. And then we have yet another unhybridized orbital. This one's coming out of the board, and the other lobe is going back into the board. Half the lobe out of the board, the other half of the lobe in the board. And then they each have 1 electron in them. And so these can bond as well, right? So that explains the other bonding here. So there's 2 pi bonds, right? So acetylene here has 3 sigma bonds and 2 pi bonds. So be able to draw these pictures. They do get quite cluttered, but you want to make them as clear as you possibly can. Using different colors helps to some extent. So let's just talk about some differences in these bonds. We'll take a look at this much later on. Let's take a look at bond length. And so when we're thinking about bond length, a triple bond is going to be shorter than a double bond, which is going to be shorter than a single bond, right? The single bond will be the longest. And that makes sense. The more electrons they're sharing, the closer they'll be together. And then we're thinking about bond strength. A triple bond will be stronger than a double bond, will be stronger than a single bond, right? And that makes sense as well. 3 is bigger than 2. However, but a sigma bond is greater than a pi bond, right? So even though a triple bond is stronger than a single bond, it's not 3 times stronger. Right, just to give you an idea, the bond strength here is approximately 965 kilojoules per mole, while this single bond is 377 kilojoules per mole, right? So you can tell that the triple bond is stronger than the single bond, but it's not 3 times stronger, right? So it's only stronger because there's 3 of them, but each individual bond, the 2 pi bonds, are actually weaker than the sigma bond.